anyway. Tumechelewa dakika kama 5 hivi. Now, I want to believe we have got some of you are from my class, others are not from my class. We have the 8 classes here today. Though the number is still not impressing as we would expect. We have 185 participants so far. So I want us to roll out the program. Then we see what we can do. This is Akim Nyaga.
Yes.
Hello, Patrick.
Good morning.
Patrick.
Yes.
Good morning.
Kidogo tu.
Sir.
I'll be coming back in 10 minutes to time to save the lesson, so you can continue. Nakuweka host, you can now control the class.
Okay.
Bye.
Oh, sasa, asante.
Oh, no. Right.
Mr. Onyango, I'm still listening.
Yes.
Okay. Now, sasa, it's okay. All right. Now, let me get Akim Nyaga.
Yes.
Good morning.
Good morning, sir.
All right. At least now we are back again to our usual work. This is, let me get now. Today we have got newcomers. Kila mtu, almost everyone today is a newcomer because we've got the 8 classes here. And I want us to join kwanza, then we move on. I am Mr. Mwanda for the sake of those classes in Funzangi. I know we've got from 1 west, from 1 south, from 1 north, all those classes in Funzangi. So we have around 5 classes which I'm new to, and most of you also are new to me. So I want us now to agree on the way forward. Ndio tuanze class yetu haraka haraka. I'll be taking the lessons of physics from today until the time that we shall close the school. So let's organize ourselves. My number I'll give to the group that in case of any problem from today and we inform one, you can reach out to me. So I have again said I'm Mr. Mwanda, wale hatujajuana nao kutoka class zingine. And let's now start our lesson. And I want to note a few members. There is someone by the name Elvis Kiongo. Elvis Kiongo.
Yes.
Good morning.
Good morning, sir.
You belong to which class?
1 Northeast.
1 Northeast. Good. Karibu. Let me get a few others. Representative Eugene Mwau. Eugene. Eugene Mwau. Eugene Mwau.
Yes.
Kindly do not unmute. Come out, Twitter, please. Let not unmute if I've not called you. Then Jeremiah Ikonya.
Yes, teacher.
Good morning.
Good morning, teacher.
You belong to my class, Southeast or Southwest?
South.
South. Oh, good. All right. Now, I want us to start our lesson. Tutajuana pole pole as we move on. Naona kina Nixon Jeru. There is someone by the name Rollins Matara.
Yes.
Good morning.
Good morning.
You belong to my class or which class? Or 1P?
1 Southeast.
1 Southeast. Good. Now I want us to start. I know we've got different sections that we've covered our syllabus up to. Wengine wako nyuma, wengine wako mbele. Some of those who belong to my class probably will repeat what we did before for the sake of the others. I want us to start pressure, tufanye kazi ya pressure purely from today, so that tumalize topic ya pressure pamoja. I know there are those in 1P, others wa Mr. Ndambuki aliniambia hamjaanza pressure bado. But I want to believe that you've read the topic by yourself. So what I want us to do is now start together, revise the areas that are of challenge, to discuss different things, and then we can now move together. Because what were 1 Southeast, 1 Southwest, and 1 South, I know we've covered these, but I want us now to start with the others so that we can run together. by the end of the term, we need to have at least winded up the topic of pressure, having done the maximum questions possible. Now, if you want to respond or if you want to ask a question, kindly can you ensure you raise up your hand? Otherwise, kama sijakuita, do not unmute yourself. Then, kama uko na swali ama hujaelewa kitu, you can either post your question on the chat or you raise up your hand. So I'll be posting questions on the chat and then I'll be calling those that I want them to respond. Or I project pictures, then if I want you to respond, ndakuita. If you have a concern, then you raise up your hand also, so that at least we're able to coordinate the class to square noisemakers and a lot of uncoordinated work. Now, to start with, I want us to believe that all of you have at least trying to read something on pressure. Then I want us to start with understanding what pressure entails, and then we move on to questions. First of all, we have to understand pressure from the perspective of the daily life situation. I want someone, this is Barak.
Yes, yes, teacher.
Nataka uniambie,
Yes.
we have a camel and a gazelle.
Yes,
Tuko na ngamia na tuko na gazelle. Zikipita
Yes.
kwa matope, ni gani itabaki a deep hole kwa matope?
camel.
A camel.
No, a gazelle, a gazelle.
Gazelle, that is Barak. Brian Jaramba.
Yes.
When we have a camel and a gazelle, they go through a muddy place. Tengeneza mashimo makubwa.
Gazelle.
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 That is Jaramba. Brian Duku. Brian Duku. Brian. Seems Brian at Kizani. Brian. Now, Emmanuel Kariuki.
Yes.
Now, I also want you to respond to these. There is
Yes.
someone wearing flat shoes, someone and another one wearing high heels. Here was Jana.
Yes.
Someone wearing high heels and someone wearing flat shoes. Wakipita kwa matope, naye atakuwa na hard time kutembea.
Wako na high heels.
Right. Those are examples now. Why do you think mtu ako na heels atakuwa na hard time kutembea?
Because the area of the heel is small, thus increases the pressure in which it will the pressure which will make the person to go down. Itafanya ikwame.
All right. That is Emmanuel. Let's now basically what we are saying is daily life application of pressure. That mtu mwenye ako na high heels na mtu ako na flat shoes akipita kwa matope, the two of them, we may assume that the two of them have got the same weight. But when the two of them have got equal weight, they pass through a muddy place. Someone who will experience a challenge of moving mwenye ako na heels will be having the challenge of moving through the mud areas. Then we will say that the two of them have got the same weight, but because one is having a low pressure low area, flat shoes ziko na high area, while the high heels have got ziko na pressure kidogo. The differing thing there is area. The difference in area will cause a difference in the pressure exerted on the ground. So let's now move on directly to understanding what is pressure. And for those who have read on pressure, I want to hear how we define pressure from one of you. Define pressure. We define pressure.
Pressure.
Mtu inua mkono. I want to see those people wenye wameinua mkono. Alex Jeru. Jeru Alex. Jeru.
Pressure
Pressure it refers to the force acting perpendicularly per unit area.
Force acting perpendicularly per unit area. That is the definition of pressure. Now, just as a reminder, for the sake of even the other classes, we have two quantities that we have mentioned in the definition of pressure. We have mentioned force and we have mentioned area. I want us to go back to the concept of measurement 1 and force, the prior topics that we've covered. We have the vector quantities and the scalar quantities. Now, I want one of you to tell me force is categorized in which type of quantity? Is it a vector quantity or a scalar quantity? Yes, someone to tell me this is a, let me get from Daniel Karanja. Daniel Karanja.
Yes, sir.
Yes, do we categorize force as a vector quantity or a scalar quantity?
A vector quantity.
What are vector quantities?
Quantities that have magnitude and direction.
They have both magnitude and direction. Then let me get from this. And I said, is imagine weird. Someone amejeka jina Bazoo. 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 What is your real name? Jina yako? Now, let's go to, let me get from Fabian Michael. Fabian?
Yes.
Fabian?
Yes.
Now, we have said we have got two quantities, the force and area, and someone has classified force as a vector quantity. What about area? Yes? Fabian? Fabian? Have you read about vector and scalar quantities? Fabian? Yes?
I have a question.
Yes, Swali?
One notice you have not yet learned vector and scalar. But when we say vector has a magnitude, when we say vector quantities have direction.
Sorry? There are those classes that there are some of vector and scalar quantities, Bado?
Yes.
Okay. Forget about that because it's not of much importance in this case, but I wanted just to have a reminder. Now, yes.
Vector quantities are quantities that have magnitude and direction, while scalar quantities are quantities that have magnitude alone.
Right. Now, kindly
Chuck,
come up
can I
on a
also
back.
answer?
I said let's avoid nini mtu asirespond because kila mtu akaanza kujiunmute before we call, we will lack control. Vincent.
Yes.
Vincent.
Yes. Yes.
Next time, let's avoid kuinua mkono eh. Vincent.
Yes.
Vincent, go on.
Yes. I wanted to say area is a scalar quantity.
What is a scalar quantity?
Area.
What is a scalar quantity?
Scalar quantity is a quantity that is fully specified by its magnitude and it has no direction.
It has no direction. So away from the vectors now and the scalar quantities, I want us to go on and then we try to understand more into details about pressure. We've said that pressure is a force acting perpendicularly per unit area. So we've got force and we've got area. So what is the SI unit of force from the previous topic? SI unit of force, John Nganga. John Nganga. John Nganga. John Nganga. Then John Nganga seems, you call John Kigodo. Kigodo.
Pardon.
My question was, what is the SI unit of force?
The SI unit of force is
Yes. John Kigodo. Kigodo.
Newton.
Newtons. Then SI unit of area. Yes, area. Since some of you are not reading physics, guys, because you cannot tell me you forgot the SI unit of area, John Kigodo. Kigodo, huwezi niambia umesahau mpaka SI unit ya area, which I'm sure every class ilikuwa imesoma hiyo measurement 1 na mkamaliza, and then mkaanza forces. So you can't tell me you forgot about SI unit of area. If you forgot even the SI unit of area, then the conversion of area means it's a problem to you by now. Can we go back to books and read? Then Vincent,
Yes.
what is the SI unit of area?
The SI unit of area is square meters.
Square meters, good. So now I want us to go directly. Then we've said that pressure is the force acting perpendicularly per unit area. Per means division. Therefore, pressure is given by, let's go to the board. Tuende kwa board. Kidogo. I want us to go. So we've said that pressure is equal to force acting perpendicularly per unit area. That means pressure is equal to force over area. Therefore, that is, and the SI unit of force is newtons. The SI unit of area is meters squared. Mtu asiandike kwa ubao, please. When you andika kwa ubao, can you get that behavior? Then the next thing is, from these, we can then deduce that the SI unit of pressure is equal to
kila mtu ataona. Hai, angalia plot. Class. Chapa tu watu.
wanafunzi anaandika. Wanafunzi anaandika.
Mpaka watu wanauliza, nani ana.
Now, who are those trying to interrupt the lesson? Kama uko tayari kusoma, si ukae nje ya lesson, please. Since some of us are here for jokes, I think you can have something better you'd be doing right now other than staying around the class interact with watu. Because I guess the kind of behavior we are displaying is not the level of a manguman. So away from that, whoever was trying to write that should know he's a madman. We move on with something else. Let's now move on. We've said that the SI unit of pressure is Newton per meter squared, and I want us now to move to understanding pressure into details. We've said that pressure is equal to force over area, and I want us to have example question that we will work on, so that at least I'm able to know what people have understood on area, on pressure, because you must have read on your own at some time. So let's have this question. I want to project a question on the board, then you work on it. let's look at that question. Vincent Mwangi.
Yes.
Someo swali.
A block of copper of density 9 grams per centimeters cubed measures 5 centimeters by 3 centimeters by 2 centimeters. Given that G is 10 newtons per kilograms, determine A, the maximum pressure.
Determine maximum pressure. Before we move on to that, I want us to understand that when we talk about the area, we are talking about the area of contact of a body that is the area of contact. Ile side imekaa chini. Now, I want us first of all to understand that is a sample question. Let me have this one, another one, before we move to calculation. We have that diagram on the board. Now, nataka mtu tufanye hiyo swali. Give me the possible area of that block. The possible area of that block that is having 10 centimeters by 5 centimeters by 8 centimeters. I want to get all the possible area of that block. Don't unmute. What do I endelea? You just get bored and go. Tufanya area hiyo kitu?
400.
50 centimeters square.
50 centimeters squared.
40 centimeters square.
3
There
centimeters
can be
square.
very many areas that can be
80
obtained
centimeters square.
from that.
80
Look for the list.
50 centimeters
40
squared and 40
centimeters
centimeters
square.
squared.
There can be very many which can be obtained. But you look for the list area.
400.
Mr. Nyango.
50 centimeters squared.
You
40
can say 50
centimeters
centimeters
square.
squared.
80
Mr.
centimeters
Nyango.
squared.
Yeah, 50 centimeters squared.
Hello, Patrick.
Mr. Nyango.
Yes.
Into a house.
Allow me disable some students from drawing those whatever they are drawing, alafu nikurudishe.
Right.
340 centimeters squared. The
Let's
area,
work
tell your say the area.
the possible areas of that question.
So you have the area.
Yes. Let's
They are
hold
giving
on.
the volume. Sure, they are
Let's
giving
keep
the
quiet,
volume.
everyone.
Yes, 340.
Yes.
340.
340 centimeters squared.
340 centimeters squared.
340.
340
centimeters
squared. Out the volume.
940
centimeters squared.
centimeters squared.
All right. Good. Now, I want us now to move on, and then we've said that the block of wood, that block. Let's go back to the block. Good. Those who are busy trying to kuchafua now, you can go on. Now we have got our block of wood, and I want us to look at that block. We've seen the possible areas of that block. Kuna area ya 10 by 5, then kuna area ya 5 by 8, na kuna area ya 8 by 10. I hope those are the only possible 3 areas we can get from that block. Those are the only 3 possible areas. Now, I want us to look to move on and try to understand when we want to find the pressure of that block. We have 3 possible areas. We have 3 possible areas that are in that block. Which area do we use when? Like Vincent addressed the first question. Yes.
Whenever we are finding maximum pressure, we use the minimum area or the least area. But when we're finding the minimum pressure, use the maximum area or the maximum area.
All right, I'm coming there. I'm coming there. I just wanted we have an introduction, something first, so that we have that block of wood in Ikwapo. Now I want to tumia block ikiwa na mass here, a mass of 40 grams, so that we now find its maximum pressure and minimum pressure. Given that the formula for finding pressure is P is equal to force over area. Let's work that question. Find the maximum area, pressure, and maximum and minimum pressure of that block if it has a mass of 40 grams. Which I want to believe that in the conversion of mass to force, we know how to convert mass to force. Like we know 1 kg is equal to 10 newtons. So you must convert the mass that we're given in Mr. Nyango. Mr. Nyango. All right. I think we'll be back soon.
How many grams?
We 40 grams.
I know you don't like me. You wanna fight me. You don't want no problems at your party. Don't invite me. I don't worry about you niggas.
Maximum or minimum?
Both minimum and maximum.
One for the party.
I'm hoping we're asking that question, please. And for this, those who cannot understand, Brian Duku. Brian. Brian Duku. Brian Duku. No, menua mkono. I don't know what your concern. Yes. Brian. Robert Gumbo.
Yes, sure.
Yes.
I found an answer for the maximum and minimum pressure.
Hold on. That's what are you going to find? Then we can discuss the question.
Okay.
All right. We can be sending our answers on the chat. If you get to answer maximum, we start with maximum and then minimum. Once you get to answer, send the answer on the chat. Now, if you don't understand what is happening, kindly ensure you ask. Don't just keep quiet.
Excuse me, teacher.
Yes.
Sorry for interrupting. There is one student who is unable to enter class.
Who is that?
Bradley Kiplimo. I don't know. He said he has tried to. He clicked on the link, but it says that you're in another meeting.
That easy. I'm a click link. Can you Mr. Mwidi?
Yes, the latest one.
Then let
Bogi.
Mwambie.
Yes.
Mwambie ongea na Mr. Mwidi.
Okay.
Excuse me, Chair.
Yes.
Chair, I joined the meeting late, so I've not understood what we are doing.
The problem now, we are fighting on pressure. Which class do you belong to?
Chai has already joined. The one.
Which class do you belong to?
1 East.
1 East. Mlikuwa umefika wapi na mwalimu?
Force. We were doing about adhesion and cohesion force.
Now we've just started introducing on pressure, and then saying that pressure is given by force over area. And we've tumeelezea about the SI unit of area, the SI unit of force. Then we've gone ahead and said that SI unit of pressure is Newton per meter square. Then we have the block of wood that we have on the board. Can you see that block? Yes?
The block.
Can you see the block I've given on the board?
Yeah.
Now, nataka uniambie from that block, how many possible areas can you get? We have how many faces on that block? How many faces does it have?
The faces. 1, 2, 3, 4, 5, 6 faces.
6 faces. But 3 pairs. 2 of them are the same, right?
Yeah. So, yeah.
Now, among the 3 pairs, each pair has got the same area. Sindio?
Yes.
If we have the face with 10 and 8, can you see that face?
Yeah, 10 and 8. Yeah. The area.
The area of that face.
Itakuwa 80 centimeter cube. Itakuwa 80 centimeter cube.
Area?
The area will be 80 centimeter square.
All right. Then the next thing is we have another face 5 and 8, right?
Yes.
Yes. Area itakuwa ni
40 centimeter square.
40 centimeter square. Which other face do we have?
The face of 10 and 5.
10 and 5. Itakuwa na area ngapi?
50 centimeter square.
50 centimeter square. Among those 3 areas, which one is maximum area? Which one is minimum area?
The maximum area. The maximum area is 80 centimeter square. The minimum area is 40 centimeter square.
40 centimeter square. Now, I want us to move on. We've said that pressure is equal to force over area. Sawa sawa?
Yes.
In getting maximum pressure maximum, because that is the question we are having, maximum pressure, we say force over minimum area.
Force over minimum area.
Sawa sawa?
Yes.
What is our force? Because we've seen the block weighs 40 grams. Come back. Commute. Come back. Step by step.
Yeah.
Now, kindly, why don't we keep silent, all of us? Nikimute kaa kando. Kama tungine wewe nyamaza kwanza. Then come back again. Na commute. Uko sawa sahi? Now, I want you to tell me, we've said that maximum pressure is given by force over minimum area.
Yeah.
Our block weighs 400 grams. Can you convert that 40 grams into force?
40 grams?
Into force.
So, 1 kg.
It is 40 times 10.
It is 40 grams, not 40 kgs.
Oh, 40 grams.
So first of all, convert to kgs. How many kgs are those? Yes?
0.04 kgs.
0.04 kgs. Now convert into newtons. What do we do?
0.4 kg.
0.04 kg times 10.
Times 10. So we got the force is 0.4 newtons.
Yeah, 0.4 newton.
And we've said that the SI unit of pressure is supposed to be Newton per meter squared. So our area is not in meters squared. It is in centimeters squared. So,
yes.
So can we convert now the minimum area and maximum area into meters squared? Convert 80 into meters squared. What do we do?
We divide by 100.
Converting centimeters squared to meters squared. What do we do?
We divide by 10,000. Divide by 10,000. 10,000.
So can you convert now 80 into meters squared? What do you get?
0.008 meter square.
0.08
0.008 meter square.
Meter square. Convert minimum area into meter square itakuwa ni
0.008 meter square.
hiyo ni maximum area. Convert the minimum
Yeah.
area which was
0.004.
0.004 meter square.
Yeah.
Now,
Yeah.
let's go to our question. The first question was find the maximum pressure. Sawa?
Yes.
Now our force is 0.04 newtons.
0.4 Newton.
0.4 newtons. Sawa?
Yes.
Let's start by finding maximum pressure. Maximum pressure is given by force over minimum area. So our force is 0.4 and our minimum area is what?
0.004 meter square. 0.004 meter square.
And tell me what to get. Divine that, tell me what to get.
Yeah.
What are you getting?
A 100 meter square.
Not meters. That is now pressure that we are getting. The SI unit of pressure is supposed to be
Newtons.
Newtons per meter square.
Newtons per meter square.
Newtons per meter
Or
square.
what else? How much?
Or Pascal. Pascal.
So that is now the maximum pressure is 100 Newton per meter square or 100 pascals. Sawa?
Yeah. Thank you, teacher.
All right. Go on now. Find the minimum pressure.
Minimum pressure.
Ni wewe nataka unimalizie hiyo because minimum pressure is given by force over maximum area.
Maximum area, yeah.
Go on.
The force maximum is 100 per minimum
50 Newton per meter square.
Good. Now nataka nifanye swali lingine na mtu mwingine hapa. I hope everyone is okay with that. James,
Yeah,
okay? James Okelo. James Okelo.
Yes, teacher.
Uko na swali ama ni answer uko nayo? Naona umeinua mkono.
Teacher, for me,
yes.
Is it supposed to be 50 or 5?
Sorry?
I got 5 Newton meter square for minimum
What was
area.
your force? Force yako ilikuwa ni? Your force was? Force yako ilikuwa ni gani? Okelo?
0.4.
0.4. Then your maximum area was 0.008. Sindio?
Yes.
So when you divide, what do you get? I'm getting 50. Check on your division.
500.
What's up?
Yes.
All right, check on your division. You're supposed to get 50, not 5. All right, next, I want to have another projection ya swali hapa that we again working on it because the best way now for us to work ni through questions. Let me just have a projection. Another question. Just a minute, we get another question.
Just the answer.
The answer is supposed minimum is 50 and maximum is 100.
Correct.
Let me just project another question hapa for you, just a minute. Let's check on that question. Kuna hiyo tuko nayo hapo. I want us to work step by step with someone, one of you, Hapa, so at least we can move on faster. Apollo Kigombe. Apollo Kigombe. Apollo.
Yes, sir. Yes,
good morning.
sir.
Nataka tufanye na hiyo swali on the board hapo yuko kwa ubao. Unaiona? Hey. Just a minute. Kama uko hapa na ignore class. What are you doing here? You have been doing something else. Let's work that question. Tufanye swali.
Excuse me, teacher.
Yes.
It is a guy known as Jonathan Muruiri. He is the one unmuting and then the music plays.
Jonathan Muruiri?
Yes.
Good. Let me just check.
Mr. Mwenda. Mr. Mwenda.
Yes, Mr. Mwenda.
Mwenda.
Yes.
Mr. Mwenda.
Yes.
Let me do that gentleman Jonathan Mwini alafu tuendelee. Kwanza nimtoe kidogo tu.
Oh. Let's keep working that question. Tufanye swali.
Excuse me, Chair.
Yes.
I can't see the measurements well.
Let me just. Can you see them now?
Mm-hmm. Oh, okay. Yeah.
Go on. The question A is find the maximum pressure, and of course the B will be find the minimum pressure. Let's find both of them. Kelvin Kariuki.
Yes.
Swali ama unataka kujibu?
What is the force? Is it the the force?
How do we find force? That question.
You work with the mass.
You work with the mass. Uko na hauna mass.
Kanairo governor ni mjamo na kuja somo.
Uko na density. The density will help you in getting the mass because you can find the volume of that thing.
Oh, yes.
Get the volume and then you have density. You can get mass from that. Senior?
Yes.
All right, go on. At least those who are taking positive thing, it's okay. With time you get just bored. What to find what is of importance to us?
Ulo kwa ngife baroda imemokre matibien kwa bambua mashashken kami.
I want to get the response from those wale si wa class yangu. I want to get from a student either from East or Northwest.
Hello Mwenda. Let me claim the host kidogo nitoe kijana mwingine hapo.
No problem.
Continue.
Nitakuokota napata mtupa kwa kaunta tu makota kona chikito nilita kama na ota kama na ota kunikisia nikachipata tu matosa lubiki ameteki movie ya ora ameteki mkono kwenye bora utadhani ana drive mkono wa left kwa gia akashikili amenipotea shika ananikia wembe
Mimi kwanza mimi nakwanga na hii music ya genge tonoe. Sina sasa.
From once.
Question Jonathan, it was that thing.
Kenyanga?
Yes. Nakupata.
Excuse me, teacher.
Yes.
Excuse me, teacher.
Mr. Mwen, yes. Mr. Mwenda.
Yes.
Let me close them out so that they don't unmute themselves, huh? So watakuwa nasikia kwa background because wanabo. Some of them are boring.
Excuse me, teacher.
Yes.
What's the mouth?
I can't understand, but I know the first step is that you change the 9 grams to kilograms.
9 what? You 9 grams to 9 grams to the density. Right? You're supposed to start the density and then you can get the volume of that block. So from the volume and density you can get the mass. And from mass you can get the force. And you go on and find the maximum area and minimum area. You find the maximum pressure and the minimum pressure.
Excuse me, teacher.
Yes.
Teacher, after changing the density into mass, what is the next step?
You convert mass into force. How do you convert mass into force?
Mass to force.
Let's say that 1 kg is equal to 10 newtons. So,
yes.
You must convert the mass to this. Then from there, you convert the mass to newton by multiplying with 10.
Oh yeah, I've got it now. Thank you.
All right. sure that we've opened the question. Let me just do another projection. Let's check on this question. Let's look at number 4. Number 4. Let's look at number 4. We are doing number 4. Let's do number 4. Let's do number 4 and number 5. Number 4 and number 5 on those, and that's on whatever projected on the board. Let's do number 4 and number 5 only. Mr. Nango?
Yes. You want me to unmute them?
No. Mute. What?
They are muted. They are muted.
Okay. Anyango?
Yes.
Unmute for me, Robert Gumbo.
Gumbo?
Yes, Chair, I haven't understood the previous question.
Robert?
How you got the answer for the previous question?
We were looking for maximum and minimum pressure, Sindio? Gumbo? Robert Gumbo? We are supposed to be getting maximum and minimum pressure, and we had density of the block required now at 9 grams per centimeters cube. We have the block. You want to find the volume of the block. First of all, find the volume of the block. Once you get the volume, you have volume and density. From the density, then you can get the mass. From volume and density, you can get the mass. Then after getting the mass, you can find the force of the block. Anyango?
Yes. Let me make you the host.
Kumbo. Robert.
Continue, Mwenda, you're not the host.
Yes, yeah, yes.
Now, what is the problem?
I wasn't able to get what everyone else was getting.
Now, can you give me the dimensions of the block? Because made already.
Well, the block's dimensions were 5 centimeters by 3 centimeters by 2 centimeters.
We know that. How do we find maximum pressure?
Find maximum pressure by force over minimum area.
Maximum pressure is given by force over minimum area. Sawa.
Yes.
We have the density of the block.
Yes.
As what?
Density of the block as 9 grams per centimeter cube.
9 grams per centimeter cube. Can we find the volume of that block?
Pardon?
Can we find the volume of that block?
Yes.
The volume is what? Gumbo.
Yes, Chair.
What is the volume of that block? Yes. Gumbo.
Oh, sorry, Chair.
What is the volume?
It's 270 grams.
No, I'm talking about volume. How do we find the volume of a cuboid? Because that is a cuboid. Robert?
Newton. Oh, okay. You find the volume by length times width times height. That's how you find the volume.
So what is the volume of that block?
Volume of the block is 30 centimeters cubic.
The density is what? Density now
is 9 grams per centimeters cubic.
9 grams per centimeters cubed. So for us to get the force of a block, we must be having either its mass or we have the force. In this case, if we have the volume and we have density, can we get mass?
Yes.
How do we get mass from density and volume?
It's density times volume to get mass.
Density times volume.
Yes.
So what is the mass of that block then?
270 grams.
270 grams. Sawa.
Yes. Yes.
Now, can you convert that into force? How do you do it? Converting mass to force. What we know is that 1 kg is equal to 10 newtons. Sawa.
Yes, Chair.
So can you convert 270 first of all into kgs? It will how many kgs?
It will be 0.27 kilograms.
0.27 kilogram. Can you now convert that kgs into force, into newtons?
It will be 2.7 newtons, Chair.
2.7 newtons. Sawa.
Yeah.
That is the force of the block. Sawa.
Yes. Yes.
Now let's go back to the block again. What is the maximum area of the block?
Maximum area of the block? That will be 15 centimeters cubic. I mean square.
And minimum area of the block?
It's 6 centimeters squared.
6 centimeters squared. Sawa.
Yes.
How do we get maximum pressure?
Maximum pressure is force over minimum area.
Force over minimum area Sawa.
Yes.
Now, can we convert our area minimum equal into meters squared? Because our area is in centimeters size, you know?
Yes.
Can you convert it now into meters squared?
That would be...
What do we do?
You are divided by 10,000 centimeters.
divide by 10,000. You convert centimeters squared to meters squared. We divide by 10,000. So can you now convert that into 16 centimeters? I mean 6 centimeters into meters squared. Itakuwa ni
0.0006.
3 ama 2?
3.
3. So that is the minimum area. Sawa sawa?
Yes.
Now find the maximum pressure.
That will be 2.7 newtons divided by 6 divided by 0.0006 meters squared.
So what do you get? What do you get?
How much? I get I got 4,500.
Fine, that is the answer.
Okay, thank you, Tia.
Now you can also find now the minimum pressure, Sindio?
Yes.
All right. So go on and solve it to on time. Then can we have this? This is Kelvin Mwangi. Kelvin Mwangi?
Yes.
What is your concern? No, mkono.
I have a question. How do you find the pressure of D?
Of?
Number 4B.
Number 4B, kidogo. Let me get the concern of number 4B. Let's now talk. Let me get the concern of also Bradley Kiplimo. Kiplimo. Bradley.
Yes.
What is your concern?
I was asking how to find the minimum area. What's the
minimum
formula?
area is given by? Sorry? Pardon?
I was asking how to find the minimum area.
Now, you have the block here ilikuwa na 5 by 3 by 2.
Yeah.
Then I want you to look at that block. Iko na size ngapi? How many faces does it have? Bradley?
It has 6.
6 sides, but 3 pairs. Sindio?
Yeah.
So we have got the face with 5 by 3. Can you see that face?
Yes.
Iko na area ngapi?
15 centimeters squared.
15 centimeters. Sawa sawa?
Yes.
Then we also have the face that is having 5 by 2. Can you see it?
Yeah.
So iko na area ngapi?
10 centimeters squared.
10 centimeters squared. We also have the face that has got 3 by 2.
Yes.
Can you see it?
Yeah.
So iko na area ngapi?
6 centimeters squared.
6 centimeters squared. Now we have those 3 possible areas. We have 15, we have 10, and we have 6. Sawa sawa?
Yes. Yes.
Now among those three areas, which one is the biggest?
15.
15 now becomes the maximum area. Sawa sawa?
Yes.
Then which one is the smallest?
6.
6 becomes the minimum area.
Thank you.
All right. Now let's have this is I want to let me just respond to someone who had asked how do we work number 4B. Just a minute. Just a minute. Just a minute. Who is that we are competing with? Kufuto Bao. Number 4B, determine the pressure she would exert on the floor if she stood on 1 foot. Kama angesimama na mguu moja. That is Bradley, I'm talking to you. I think you are the one who had that question. you are told that a girl standing upright exerts a pressure of 15,000 Newton per meter squared on the floor. 15,000 Newton per meter squared. Then given that a total area of the contact of the shoes and the floor is 0.02, determine the mass. I want us to start. Nani alikuwa muuliza hiyo swali? Ni someone by the name kidogo. Let me just hi hand. Kuna mtu alikuwa anauliza hiyo swali. Let me just check who is this. Just a minute. Just a minute, guys. I don't know what is not happening. Easy vitu tunafanya kwa bao. Really, I didn't expect this one could come from anyone in Mangu. Unless someone is telling us you don't belong to Mangu ama kuna wageni wako huku. This is not behavior of guys from Mangu. Now let's look at that question. I don't trace whoever was asking that question because that's doing in Nimba. Kelvin Mwangi. All right. Let me just now unmute you kidogo then tuongee. Not happening. Kidogo, guys, I don't know why the app is hanging. Just a minute. Now, Kelvin Mwangi, I want us to. I don't expect this one to come from you guys. Swali hata ionekani, you cannot now. What you guys are doing is just hell. I didn't expect this one to come from you. Simon?
Yes, teacher.
What is your concern?
Can you just start in that question 4? Can you just start from A?
All right. Now I want us to work together. Soma hiyo swali. I hope umeandika. Umeandika?
No.
Umeandika because now let me just go back to the question. Dakika moja. Let me get from my projection. the question is let me get the question kidogo, just a minute, because some of you have decided kuchafua kila kitu. A girl standing upright exerts a pressure of 15,000 Newton meters squared. Now, then we are told that given that the total area of contact of the shoes and the floor is, the area is 0.02 meters per second squared. Determine the mass of the girl. Now, how do we get pressure? Yeshoge?
Pressure, force over area.
Huh? Force over area. Sawa sawa.
Yes.
We have pressure. Can we get force? We have pressure and area. Can we get force?
Force.
Is okay?
Can you repeat? Can you repeat?
Force is given by?
Force.
Yes. Force is given by? From that formula of P is equal to F over A. Is okay?
Yes, teacher.
Umepewa pressure, si ndio?
Yes.
Umepewa area, si ndio?
Yes.
Can we get force?
Yes.
How do we get force? When we have what we know is that pressure is equal to force over area, right?
Yes.
Now we have pressure, we have area. Can we get force?
Yes, you take pressure, you multiply by the area.
So what is the force? Multiply uniambia ni ngapi? Our area is 15,000 and our pressure is 15,000 and our area is 0.02. What do you get?
30.
You getting 30?
Yes.
Is it 30 or 300? It's supposed to be 300, not 30. I'm the one with the wrong thing. Let me just multiply times 0.02. You're supposed to get 300, not that.
Oh, yes, 300.
So our force is 300 newtons.
Yes.
Then from force, can we get mass? Because we know that 1 kg is equal to 10 newtons. So we have 300 newtons. How many kgs are those?
You divide by 10.
So you get how many kgs? That is the mass.
Kgs. Oh,
that is the mass. We now move on to the next question, number B, which was determine the pressure she would exert on the floor if she stood on 1 foot. Now, if she stood on 1 foot, akuwa na miguu mbili, alikuwa na area ya 0.02. Mguu mmoja itakuwa na area ngapi? Is okay?
Yes, teacher.
The question is, determine the pressure she would exert on the floor if she stood on 1 foot. Miguu mbili ilikuwa na area ya 0.02. Sawa sawa?
Yes.
Mguu mmoja itakuwa na area
by 2.
You get what?
0.01.
That is the area itakuwa na
0.01.
Now, we have the area at 0.01. Na force yake ina maintain ile tu ilikuwa 300 newtons. So what will be the new pressure?
Yes.
The new pressure will be?
Force over area 300. $30,000.
That is the answer. Somebody else? Ameinua mkono.
Yes.
All right. Let me just check who is this. Mohammed Adan. Mohammed Adan. Swali. Mohammed. Look on mute. Mohammed, can you talk? Mohammed, hausikiki? Toa headphones kama umevaa headphones. Toa hizo headphones. Mohammed. Voice yako iko chini, hausikiki Mohammed. Hello. Yes, now ongea. Kai. Umepotea kabisa, wewe hata usikiki. Let me get from someone I can hear. Let me see this. This is Kevin Kariuki. Kelvin Kariuki.
Yes.
Kariuki. What is your concern?
My question was, how do you use the gravitational acceleration?
Gravitational acceleration is supposed to convert mass into force.
Oh, so for you to find the weight.
Yes, so that you can find the weight.
Okay, thank you. Yes.
Oh, karibu. This is let me get from the concern. Who else has a concern? This is Mr. Onyango. Mr. Onyango. There is someone by the name. This is the former host. I think this is Mr. Onyango. Nawonge. Benson Madari. Benson.
Check, can you hear me?
Yes, I can hear you. Ongea.
I was asking of number 5. Could you project the question again?
Number 5. Just a minute.
Mr. Mwenda.
Yes, Mr. Onyango.
Like around 3 minutes to time. Huh?
Yeah.
Oh, fine.
Oh, let me just. The question was. Andika your swali, then sometimes later we can discuss it. Someone is sharing on the board. I don't know.
Sure.
Yes.
If the question cannot, I was asking where when we are finding the minimum pressure of number 5, I found that the force was 2.4.
The force was
2.4.
2.4. Let me
Yes.
just protect your swali. Number 5.
Number 5, yeah, a block of density. When I was doing for the force.
Mr. Nyango, kindly give us around extra. Mr. Nyango, give us around 3 minutes extra. Go on.
When I was doing for force, I found 2.4 newtons.
2.4
newtons. Yeah, and when it was finding the minimum pressure, and I did for the maximum area, which was 60 centimeter. Yeah, I found my answer to be 400 Pascal. I don't know where I went wrong.
The others are getting. What are the others getting?
The others are getting.
What to do, because naona time yetu ni kama inaisha. What you do? Kuja kwa inbox yangu sawa.
Sawa.
Come to my inbox. Uko class gani?
1 East.
1 East. Fine. Ask Mr. Mwedhi akupatie namba yangu kwa nini? Ask Mr. Mwedhi akupatie namba yangu, then you come to my inbox in the response.
Sawa.
All right. Well, I think we can stop there, guys. I think today, to some point, the last minute of the class ilikuwa mzuri, but tulianza vibaya, and we still have someone who is busy disturbing us. I would kindly wish to say that kama uko poa na kuja class, why don't you do something else? Yule mtu anataka kusoma asome. Kama utaki, wewe kaa tu tulia, do your work. If you don't want to be helped, just stay at your place. Don't come and disturb us. It feels so bad to see that someone from Mangu can just come to disrupt. Yani unakuja kuharibia wengine wasisome. I wish we had a better way of doing it. So we stop there and then we meet next Thursday. And next Thursday we'll have a more coordinated class. At least now most of us are not badly off. We have a few guys when wameamua kuharibu. But we'll know what to do with them. At least we have identified around 5 of them. So we take them to disciplinary action so that next time they won't disturb us.
Yes.
Next lesson, tutakuwa na better coordinated one. But I think today was good. Not badly off. Apart from few who came up disturbing.
Yeah.
So we stop there. Mr. Nyango, I think we can now discontinue the lesson.
Hello.
Yes, Nyango.
Hello. Yes. Oh, umemaliza?
Umemaliza. I think we are through.
Okay, that is fine. So actually, some of those boys who were disturbing, I've noted some of their names down.
All right.
And I'll do some follow-up. So I don't know why they just had to come in and spoil like everything. You are busy there explaining and they're like, but we'll follow up, don't worry. So the lesson was okay. We appreciate your efforts.
All right, thank you.
Looking forward to see you next time. Thank you.
Thank you.
And to the students who are here, please, when you come to class, be serious. You know, this thing costs a lot of money for the school and also the parents are paying for them. So if you don't want to learn, there's no need of coming here, drawing nonsense or writing nonsense or playing music on the background. We all have gengeton. You've listened to them. We know what they're supposed to be doing. So ukikuja hapo kutuplay gengeton, you're boring. Next time I may not admit you in. So let's Benson Mandari.
Mandari? Then can we behave like we are Mangu men? Because the kind of conduct some of you are displaying is just pathetic.
So, Mwenda, have a good day. Let me save the videos and everybody should leave.
Mr. Nyango?
Yes.
Only once you save the video, nitumia sai.
It's going to the link. Inaenda kwa link ya shule, so it must be processed first, then it will come back.
All right.